Hi there, this is Shamin here. In this video, I'm going to teach you periodic tables of elements and draw the electronic.
How are elements arranged in the periodic table?
Hi there, this is Shamin here. In this video, I'm going to teach you periodic tables of elements and draw the electronic structure of elements with the help of periodic table and describe the characteristics of metals, non-metals, and metalloids, and also recognize and periodic properties based on the chance in periodic table. Alright, so let's get started. Periodic tables contains the atomic mass, atomic number, and chemical symbols that is associated with known elements. So today 118 elements in the periodic table. Rho is called a period, and each element's atomic number increases as you move along the period. All right. Column is called a group, and elements in the same group all have the same number of valence electrons in their outer shells. So what do you mean by that?
Now, we'll study the structure of the atom. Behind what we can see in the periodic table. We'll look at the element's electronic structure. So here is the electronic structure illustrates the electron arrangement of an atom of an element. Electrons can be shown as a cross or a dot, and electrons occupy energy levels, also known as electron shells.
All right, so oxygen atomic number is 8. So we'll start with first shell. This one, the first shell. So here is 2 electrons can be first shell, and then we have still have 6 electrons. So we will add here second shell. That is, we will add here 6 more. Then we total is a 8 atomic number. That is the electrons in total. All right, so oxygen atomic number is.
So here is the electronic structure here, first shell and fourth shell. Follow the rules below when drawing the electronic structure of an element. Number 1, 2 electrons in the first shell and 8 electrons in the second shell, 18 electrons in the third shell, and 32 electrons in the fourth shell. All right, let's see. So here you go. So if you see here, this is oxygen. So atomic number is 8. So first shell will take here, always start with the first shell and work your way outwards. Note that only 2 electrons can be on the first shell. And what's the second step? That is the second shell. So oxygen still has 6 more electrons. We can place that on the second shell since it can have 8 electrons in total.
All right, now I'm going to draw a electronic structure of an element that is oxygen. All right, so we need.
So here is the electronic configuration. So identify how many electrons are in the shell and follow this format in writing electronic configuration. Learning check. Draw the electronic structure for lithium, sodium, and potassium and write the electronic configuration for each element. And what change do you notice regarding the atomic number and the electron in the outermost shell?
Potassium, that is atomic number is 19. So we'll start here. This is the first shell. So we'll take 2 here, and then we have 8, 1, 2, 3, 4, 5, 6, 7, 8 we have, and we have more. So we will take one more, 1, 2 here, 2. So we'll draw one more. All right, so now total we have 19 atomic number and electronic configuration, that is a 2, 8, 8, and 1. All right, so we'll draw one.
Here's a learning check. You need to check here. The atomic number increases down the group, and the atomic number tells you how many electrons each element has. And each group one element structure has one electron in its outer shell. Elements are grouped together by the number of electrons that they have in their outer shells. So here is the properties of metals and non-metals. That is, the shiny metals, good conductors of heat, electricity, malleable and high density, high melting points. And non-metal, that is dull, poor conductors of heat, electricity, or brittle, no and low density and low melting points. Trends in metal group. So that is the as the atomic radius increases, the electrostatic force of attraction becomes weaker between the positively charged nucleus and outermost electron, that is the valence. So these increases the reactivity down the group. So that is the reactivity increases. Fluorine is the most reactive in this group because its outer electrons are close to the atomic radius of the positively charged nucleus, making it easier for an additional electron to be attracted to fluorine. Down the group, the atomic radius gets larger and electrostatic attraction becomes weaker, making it harder for group 7 elements to attract one additional electron, that is, reactivity decreases. So complete this table. Here's the metals and non-metals, and here's the properties, appearance, conduction of heat and electricity, and density, melting point, chance in reactivity. So here's the answer key, guys. I already given the difference between metals and non-metals properties. Here's a summary, guys. That is, the modern periodic table organizes elements by atomic number, revealing their structural arrangement. Elements' positions in the periodic table reflect their atomic structure and outer electron arrangement. Similar properties among elements within a group on the periodic table can be explained through identifiable trends. Metals and nonmetals exhibit characteristic properties that can be identified through their placement on the periodic table. So here's a guys your assignment task, that is research what an ion is and the rules about how ions are formed. In addition, explain the charges assigned to each group in the periodic table and use your images to illustrate your explanations and present your findings using the whiteboard feature. So you can use Canva apps. That is fine. Okay, thank you guys and see you later.